Guys, it's finally happening. After nearly a decade of development, longer depending on how you count, NASA's first Space Launch System core stage is being stacked in the Vehicle Assembly Building to launch the uncrewed Artemis 1 mission to the moon as early as this November. Before I get into the video though, I want to welcome all of my new subscribers and thank everybody for engaging in comments. I really appreciate it. If you want to join this community of human spaceflight enthusiasts outside of YouTube, consider joining our Discord server. And if you want to help me in my goal to focus on orbital velocity full-time, I've set up a Patreon page. Depending on the level you pledge at, you can get access to exclusive graphics, provide input on scripts, and even get your name in future videos. You can use the QR codes on the screen or click the links in the video description below. If you can't support Orbital Velocity financially, no worries. All you need to do is watch and share this video and launch that like button into orbit. Don't forget to subscribe to the channel and turn on notifications so you don't miss another video. Now let's talk about this gigantic moon rocket NASA is building in Florida. The Space Launch System is truly a monster rocket. The Block 1 variant, when fully stacked, is to stand 98 meters. That's taller than the Statue of Liberty from its foundation to the top of its torch. Combined with two 5-segment solid rocket boosters, the liftoff thrust of the SLS rocket is expected to be nearly 40,000 kilonewtons, about 15% more than the Saturn V. While the boosters are expected to burn for about 2 minutes, the core stage with its engines is to continue nearly all the way into orbit, some 8 minutes after liftoff, to drop off its mission payload. In the case of the Artemis 1 mission, that payload is the Interim Cryogenic Propulsion Stage, or ICPS, and the Orion spacecraft, minus the launch abort system, which is jettisoned shortly after the boosters fall away. The ICPS's RL-10 engine should then briefly ignite to push itself and Orion into a parking orbit in preparation for its multi-week uncrewed mission around the moon. The SLS core stage itself, which is in many ways based on the Space Shuttle era's external tank, is 8.4 meters wide and 65 meters tall. It was assembled at NASA's Michoud Assembly Facility in New Orleans, which is also where the Space Shuttle's external tank and the Saturn V's first stage, the S-1C, were built. The core stage has 5 main parts: the forward skirt, the liquid oxygen tank, the intertank, the liquid hydrogen tank, and the engine section. When fueled, the liquid oxygen tank holds 742,000 liters of, well, liquid oxygen at minus 183 degrees Celsius, and the liquid hydrogen tank holds 2.03 million liters of liquid hydrogen at minus 253 degrees Celsius. The engine section has 4 upgraded Space Shuttle era RS-25 engines, which produce a combined thrust of nearly 7,500 kilonewtons at liftoff. NASA is currently in the process of stacking the rocket's elements inside the Vehicle Assembly Building located at NASA's Kennedy Space Center in Florida, the same location where the iconic Saturn V rockets and the space shuttles were assembled. Much like the space shuttle stacking process, NASA started stacking the 5-segment solid rocket boosters on the mobile launcher in High Bay 3. The aft segments were attached to the mobile launcher first, followed by the other 4 pieces in forward assemblies, or nose cones. This was done between November 2020 and March 2021. Next attached, per the topic of this video, was the core stage. It was lifted from the transfer aisle, where it's been since its arrival at KSC in late April, and moved over and into High Bay 3 between the 2 solid rocket boosters. The core was joined to the booster's aft and forward attach points located on the engine section and intertank, respectively. Once everything to this point has been checked out, the next step will be to add the launch vehicle stage adapter, which is basically an inner stage that holds the next part, the Interim Cryogenic Propulsion Stage, to the rocket. At this point, the ICPS will be moved from the multi-payload processing facility at Kennedy Space Center into the Vehicle Assembly Building to be stacked. From there, the Orion stage adapter is mated to the top of the ICPS. Finally, the pre-assembled Orion stack, which includes the spacecraft adapter, the European service module and its encapsulation panels, the Orion crew module, and the launch abort system, will then be added to the top, capping off the assembly of the first human-rated moon-bound rocket since 1972. While it seems like launch is now just right around the corner, and compared to its development pace, it really is, there is still a lot of work that needs to be done. Once the ICPS and Orion stage adapter is stacked, likely later this month or early July, a mass simulator for the Orion stack will be added first in order to perform a modal test, essentially ensuring the stack can actually withstand the various vibrations expected to be imposed on it during ascent. While each part has been thoroughly tested individually, this is the first time a full SLS stack has been assembled on a mobile launcher. Once those tests are complete, the mass simulator will be removed and the Orion stack assembled in its place. If all goes well, the final stack could be ready for systems checkouts and rollout to Launch Complex 39B for a wet dress rehearsal, meaning a full countdown and fueling all the way until a few minutes before the engines would ignite during an actual mission by early fall. Internally, NASA is still targeting late November for the launch of Artemis 1, however it's possible this could slip to the first couple of months of 2022. It's been a long road to get to this point. I'm going to skip over a lot of the twists and turns of NASA's deep space human space exploration ambitions over the last 16 years. Go watch a video about that right here. Development for SLS formally started in 2012, however testing for some of the components began under the now cancelled Constellation program as early as 2009. For a number of reasons, both cost and technical, the first flight of SLS has been continually delayed from its initial goal of 2017 to now no earlier than later in 2021. Once the Artemis program was announced in 2019, NASA and the core stage's prime contractor, Boeing, worked to find ways to accelerate the final assembly of this first core stage, which was still behind schedule. The long lead item at that point was the complex engine section, which traditionally was to be stacked first in the vertical position. In a bid to work around that issue, it was decided to do the final mating of the core's hydrogen tank and the forward join, the intertank liquid oxygen tank and the forward skirt, on its side. Once the engine section was completed, it too was mated horizontally. In early 2020, the core was shipped via the massive Pegasus bars from its factory in New Orleans to the Stennis Space Center in Mississippi for what's called the Green Run. The Green Run was a series of 8 tests on the core stage while it was perched atop the B-2 test stand, culminating in a full-duration hot fire of all 4 RS-25 engines. Additional delays because of technical issues, inclement weather, as well as a global pandemic pushed the final test to January 2021. However, that hot fire test also had an issue, which caused the engines to shut down after only a minute of burn time. It turned out that an overly conservative test limit on an engine's hydraulic system was exceeded. This was adjusted, and NASA and Boeing opted to perform the test again in March. This time it fired for a full 8 minutes as planned. After this was completed, the stage was removed from the B-2 test stand and placed in the Pegasus barge to be shipped to KSC in Florida, where it is today. Once Artemis 1 finally launches, it'll send an uncrewed Orion spacecraft on a multi-week mission around the moon to certify it and the SLS for human flight on the next mission, Artemis 2. Artemis 2 won't take nearly as long as it did for Artemis 1 to get to the pad, hopefully. Already, the core stage for that mission is in advanced stages of assembly at Michoud. As things stand now, Artemis 2 is to launch as early as late 2023 with 3 American astronauts and 1 Canadian astronaut. That mission, with nearly identical hardware, will use an ICPS to push Orion into a very high Earth orbit to verify long-range communications and deep space rendezvous techniques. Then, once Orion gets close to Earth again, it'll fire its service module's engines to place it on a free return trajectory around the moon. In total, that mission is expected to last for just over a week and will see the first humans to travel into deep space since Apollo 17 in 1972. Already in the early stages of construction is hardware for the Artemis 3 mission, slated for 2024 or 2025. If everything stays the current course, that mission could see the first humans land on the moon's surface since 1972. While NASA is billing the SLS as the most powerful rocket ever built in terms of liftoff thrust, it's possible that may only ever be true on paper. SpaceX is currently developing its Starship system, which includes the Super Heavy booster. Its estimated liftoff thrust is initially expected to be around 72,000 kilonewtons, nearly twice as powerful as the SLS. However, neither vehicle has flown yet. SpaceX's first Super Heavy flight could come as early as this summer, but delays are bound to happen. While it's easy to criticize SLS's performance and cost over the last decade, and believe me, there's a lot to criticize, it's important to note the different developmental philosophy of SpaceX and traditional aerospace. While Artemis 1 is a test flight, it's a full mission with many objectives in deep space. The first orbital flight of the Starship system will only be a single orbit, and its likelihood of failure is probably pretty high. And that isn't at all a bad thing, because SpaceX is working on a rapid pace of iteration and testing. They can expect early flights to fail. Artemis 1, on the other hand, can't fail, or it delays the entire program, or worse. Moreover, now that NASA has selected SpaceX's lunar Starship to be developed for the first human landing in more than a half century, teaming up SLS with Starship is possibly the best outcome for the Artemis program. SLS can be used for human payloads since it has a launch abort system, and Starship can launch an extreme amount of cargo to the moon while still being a fully reusable system that can be refueled in low Earth orbit. This is #TeamSpace at its finest, and I, for one, am excited for the future of SLS, Starship, and the Artemis program. So what do you think? Will SLS and Artemis 1 fly before Starship Super Heavy? And regardless of timing, are you excited to see this thing finally take to the skies? Let me know in the comments down below. And if I've earned it, it'd mean the world to me if you could subscribe to the channel and share these videos with friends and family. And don't forget to launch that like button into orbit if you haven't already. Also, if you're able, consider supporting Orbital Velocity on Patreon. Depending on the level you pledge at, you'll get access to graphics and content not used in videos, as well as your name in future videos published on the channel. Finally, be sure to follow Orbital Velocity on Twitter and Facebook. You can also visit orbital-velocity.com for even more space-related content, including a monthly newsletter called The Space Capsule. Links are in the description below. Thanks again for watching, and until next time, ad Astra.